Welcome everyone to this week or this month's session. This month we're going to have a couple of guests that I think are just fantastic. We've got a great session lined up here. Jake, for those of you that don't know Jake Lovasolo, Jake has been around. He came from Cisco, came to Cisco from July Systems. But he's been around the whole spaces context from the beginning. And I would say, both Jake and Jerry are kind of like when you have these guys that you go to for help on a regular basis. Jake and Jerry are both super knowledgeable, super nice guys that have always been there whenever I've needed help. And so I'm just really excited to have them on the session today. And we're going to start off with Jake going through a little bit around spaces, some of the spaces use cases, and then he's going to take us into the spaces planning tool. And then Jerry Alla, and by the way, Jerry is head of the technical operations at Hamina. And so he's going to walk us then through how to take that to the next level. And this, I think, is one area that in particular we've sort of been missing. We've had sort of the ability to get close and spreadsheet math and that sort of stuff. But now we can really take it to the next level in terms of being able to plan accurately for location. And Jerry's got some stuff up his sleeve that I don't think we've shared publicly yet. Jerry, is this kind of the first time we're letting this one out of the bag?
Yeah, we've got some new features that'll align well with this webinar, so I'm happy to kind of debut that here.
Awesome. So that's going to be fun. All right, I'm going to turn it over to Jake. Jake, if you want to just kind of maybe start us off and take us through the spaces use cases.
Yeah, definitely will do, and appreciate the intro, Al, for the team. So I'm going to kind of start with some big picture, general overview of what Spaces is and kind of how it's evolved to where we are today. Talk about some of the challenges that we see when our customers are aiming to solve some type of location issue, location challenge. And there are all kinds across all different kinds of verticals as well of where these challenges are coming up and kind of how Cisco, even beyond just Spaces, but Cisco as a whole is what we think pretty uniquely positioned to solve them, to make these deployments easier, to make the cost of ownership lower, and to do them faster. So I'll kind of go through the framework and why we think it's relevant, talk about some specific use cases, and then we'll talk about where do we start. We can identify all these use cases that we may want. What do we do now? How do we know where to get started? And that's where I'll pass it over to Jerry, who will map out exactly what those next steps look like. So I'm going to pull up some PowerPoint here before I jump into some browser. And I'll kick it off kind of just with the general problem statement. And thinking about the network for a smart space is kind of changing the way that we historically have looked at network and infrastructure, where it's so much for connectivity with security and whether it's a wireless access point or a collaboration device in a wall like I'm talking to, it has its core purpose, right? And a lot of times the association isn't necessarily made that same infrastructure and the same equipment that we're putting in our ceilings for connectivity, whether it's Wi-Fi 7 access point, Wi-Fi 6, is also a sensor that can be used to bring all the intelligence that's already flowing through an environment to be used for so much more, right? So apart from just connectivity and security, which obviously is extremely important, but now how can we use that for potentially line of business type outcomes like wayfinding, safety and duress, asset location, occupancy analytics? A handful of these I'll kind of talk about throughout. And this evolution now has been ongoing, right? And so Al mentioned I came from July Systems. That's relevant because that was about 7 years ago now, where Cisco wanted to kind of redefine the next generation of location and location data, and how can we do so at scale and maximize the value from our infrastructure. So since then, it's kind of the mission statement has really been to connect people and things with the physical world and what's happening then digitally. So you can see some of the amount of space that has been onboarded into the platform to date, and why that's relevant, especially for some of the really mission critical type use cases that we're going to talk about, where you need to deploy a network and an infrastructure and solutions that could really be life or death situations in some cases in some of your environments. And so kind of going through and looking at what some of these challenges are, right? And this is a bit broad. It's going to be across a couple different verticals, whether we're talking about a workplace and needing to deliver on employee and visitor expectations of earning their commute into the office, being able to get visibility into how a particular space or environment is actually being utilized. Think of, what day of the week is the busiest? What's the peak hour of the day? Is this conference room being used ever? All different kinds of intelligence that we can gather, which then also feeds into the challenge of no real clear strategy around using this intelligence to be more sustainable, save or increase our energy efficiency, being able to look at the operational efficiencies, so asset location, and being able to reduce any kind of time that is reducing the actual output and productivity because we have to find a critical tool, a critical asset, a critical piece of equipment. And then last but not least is safety and looking at moments of duress. How can a network be able to, at scale, deploy this reliably in a way that is going to deliver on the expectations that you and all your teams that you work with would expect? And so this is now where kind of breaking this up into three different sections of kind of how we see Cisco being able to solve for some of those challenges from the previous slide. And it starts with the hardware foundation. And so obviously we're talking a lot about wireless here on this call and Wi-Fi 7 and how important that is of a launch point and all the value that comes from these access points, which I'll talk about more on a slide or two, but also collaboration devices, IoT sensors, all of these pieces of equipment now that are really the foundational elements of turning your space into a smart space. The next piece of this is the software platform and the middleware. So kind of think of this now as the operating system for your building. What does your operating system need? When we're talking about a smart space and location data, we need to have a consistent and a relevant mapping layer that's very contextually aware and spatially aware of what your space is, knowing that a desk is a desk, a room's a room, zones are zones. There's an occupancy of 6 people in this room. We need to have APIs. We need to be able to integrate with IoT devices. All different kinds of components that really roll into this operating system that then lay the groundwork to deliver outcomes. And these use cases can vary across all different kinds of verticals, whether we're talking about healthcare and we're talking about asset location and staff safety, duress, wayfinding, Wi-Fi onboarding, talking about a carpeted workspace environment and being able to get into space utilization or occupancy, environmental monitoring, all of these different outcomes now that layer on top. And so double clicking on kind of that network as a foundation and the hardware relevance. So often when we think about a wireless access point, we're thinking of connectivity and we're thinking of the speed and the feed and the throughput and the security, and all of that obviously is extremely important. But that access point is also a sensor, and that sensor can tell us where is this device located. It can tell us how many people are on a floor or in a building. That access point can be a gateway to integrate with all different kinds of third-party sensors, beacons, lanyards, you name it, from a mix and match of different vendors even, without deploying an overlay gateway network. So now all running through that wireless access point, you can start to broaden out the numbers of use cases that are deployed on top of it. And you can see, of course, there's collaboration devices like what I'm talking through right now. It's not just for collaboration, but it's also a sensor to be able to tell corporate real estate that this room is occupied and that there was one person camping out in this 6-person room all day. And then you can see some of the other elements here. And it's, again, all layering on top of this operating system. And so I'm going to, once I get to the demo, I'll real quickly kind of flash what these AI maps are and why they are relevant, why they're important across verticals and across use cases for outcomes with different stakeholders throughout your organization. Once we have that map, now we can compute location, we can place access points on a map, we can derive at what occupancy is, we can derive to different applications and APIs. So really foundational piece now that we can start to layer on different use cases. And why I'm harping on that operating system component so much is because this is a very simplified view of what so many of our customers' environments look like, right? So they'll have one use case that they're going to go and solve for with an overlay stack, a proprietary silo, and that will be for one use case. So if we're working left to right, it's going to be occupancy. We're going to go look at an overlay deployment of sensors, which is going to be a cable run. It's going to be costly. It will take time to deploy. And now you're managing another set of infrastructure. And that those sensors will only speak with that vendor's gateways. And that those devices are only going to speak to that vendor's applications. And now start to multiply those out across different use cases, across different stakeholders, and you get complexity. You're going to get higher costs because of the proprietary nature of these. It's going to be obviously very scale limited, and then the security components of it. And so what we've wanted to do is kind of break down these verticalized stacks and these verticalized silos, and instead now really open this up, broaden it out, and add that horizontal element. So all that hardware as a foundation that we talk about, access points, collaboration devices, IoT sensors, all of those now can mix and match, even on the IoT sensor side here, where it can be third-party devices. So I'll kind of flash what some of those might look like. But now they're all kind of standardized and integrated because of that Spaces operating system, because of the gateways inside of our access points, and because of that mapping layer. Now you can start to deliver outcomes. And those outcomes can come from Spaces natively, and I might show what one or two of those might look like. I'm going to have a slide here in just a minute on kind of the ecosystem and now how the ecosystem benefits and your deployments with some of those partners can benefit because of this framework. Or if you have your own applications, your own data lakes, now you're only taking that from one stream of data, kind of standardized regardless of what piece of hardware it's coming from down here. Don't have to deal with the separate stacks and silos that we saw in the previous slide. And so I talked about that ecosystem. This is so important now because it's much more standardized on both on the device side and on the application side. And so regardless of what vertical you're in, there are going to be situations or use cases or requirements that are going to funnel you into some of these kind of best of breed, very vertically specific partners. And like I'll reference healthcare as an example. There's the Securitoses, the Centracs, the Aristaflows, the Contact IOs that live, eat, and breathe healthcare-based use cases. Now, if we can at scale simplify those deployments, run it on our wireless, simplify the deployment of it with a few clicks of the button from the Spaces dashboard into those tools to start that data flow. Now that's a win for the entirety of that solution. And it also then comes out to be at a much lower cost. So here's kind of a reference of if you're running those stacks, if you're looking to solve these use cases, and let's just say asset location in a hospital, rather than comparing it or looking on the left-hand side of an overlay solution where you're going to go and put that proprietary gateway in and you're going to drill holes and run cable for it and lock in with that vendor, rather than reducing the cost of ownership because you're leveraging infrastructure that may already exist in your environment today. So lots of ways now where we can increase the speed to value, lower the total cost of ownership. And that's all because now we have this common framework. So we have standardized location. We have one system that's calculating XY coordinates across use cases. We have that mapping layer, the IoT elements where we can layer on different types of sensors and devices. And then one stream of API that's going to aggregate all the data from these different systems. And now that can start to benefit us from anything from kind of something as foundational as placing access points on a map automatically. And this is now like once they're actually hung, where the access points can speak to each other, and we need to know the network placement of those access points where they're deployed, so that now we can use that to calculate location. It gets into tracking assets or locating clients for troubleshooting purposes or for actual operation purposes. It gets into being able to display this telemetry, whether that's to employees and visitors that might be walking into your space, whether that's a carpeted environment like I'm in, whether that's a healthcare environment, to be able to display where certain departments or where certain appointments might be. And then indoor navigation, be able to leverage that same access point as, and the BLE radios inside of them, as a tool to be able to give this device blue dot turn by turn directions to get wherever I might need to go in that particular space. And so now this is going to deliver use cases and outcomes across verticals. This obviously is not an exhaustive list, and I'm going to kind of deep dive on a couple of them here, particularly workspaces and healthcare, and what those look like and kind of how we deliver them, and whether it's natively or through partners. But wanted to kind of show you the breadth and the depth of some of the outcomes that come because of that hardware foundation, layered on with that Spaces operating system, and now the use cases that come on top. And so if we're looking at workspaces and corporate environments, kind of this starts with being able to display and visualize all this data that we have because of that hardware foundation. We know how many people are in a building or on a floor. We know which conference rooms are utilized or not. We know what the temperatures and the humidities are because of different IoT sensors that are integrated with our wireless. We can deliver turn-by-turn directions to this device because of the BLE radios inside of the Wi-Fi 7 access points. And obviously deployment of those becomes important, which we'll talk more about. Thinking back to one of the first slides I showed with the challenges and the problems, and not having any ability to really deliver on sustainability use cases or limit our energy consumption. Now, because we have this telemetry, we can now communicate with different building management systems. The occupancy analytics, being able to show which floors are being utilized at certain percentages against capacity on what days of the week, at what hours of the day, and then giving employees an ability to find and reserve desks. And then the next one I'm going to show here is within healthcare. So many different touch points with visitors, with patients, with staff, that it kind of starts now with being able to get this device connected onto Wi-Fi in a seamless manner. Once that device is connected, now I can start to push communications and engagements to them. If they have connectivity, now being able to deliver navigation and turn-by-turn directions to them. But then also looking at kind of really critical use cases, whether that is tracking infants or patient safety, patient protection, or staff safety and duress. Again, all layering on the same hardware foundation and the same operating system. Or if we're looking at tracking of assets, whether that's Wi-Fi based, BLE based, ultra wideband, especially on the Wi-Fi 7 access points. And then some of the environmental and temperature monitoring that we can do with some of those devices that are integrated. And so talking about a lot of different use cases, and now this is going to kind of get into where do I start and what do I do next, right? And kind of the question when we're thinking of deploying our wireless network, we're deploying this wireless network for the next handful of years. And so if one of these use cases may be on the radar for the future, it's important to consider today and plan accordingly, that there may be a time where I'm going to need to deliver asset tracking to the business or to my different stakeholders. There may be a time throughout the life cycle of this wireless network and the investment I'm making in it that I want to do indoor navigation. And so if any of those boxes are checked as a consideration that you're going to want to consider or deploy, then the right infrastructure, the right density, and the right placement all matter. And that's where, especially once I turn it over to Jerry, he'll kind of show how we can fine tune this and make sure that these use cases are going to be deliverable on top of your infrastructure and that you're planning accordingly. I'm going to show a couple tools here on kind of where we're at and kind of how it's evolved, and then I'll show kind of step 0 of that planning process, and then kind of the segue over to Jerry of what you do with it. But I'm going to flash just a couple things first. And all this is are kind of tools and demos that you can access through Cisco Spaces website. But to kind of show the breadth of these devices, and I talked about breaking those silos and those different stacks and being able to mix and match with different vendors, being able to look at the whole slew of different IoT devices that are pre-integrated, pre-validated on top of our wireless infrastructure across all different kinds of use cases, where you can come in and choose whichever outcome it might be, and you can get an idea for different price points, different form factors, different battery lives, and you can layer on all these different vendors and all these different types of devices you with a couple clicks of a button, where you claim them using an order ID. They show up in your Spaces dashboard, where you can now start to manage, configure, deploy these at scale. Again, without doing any overlay deployments. So this kind of broadens out the use cases now. And as you guys start to explore, I want to do asset location, is there a preferred vendor? So many different tools or solutions that would be kind of pre-checked and pre-validated here.
AJ, quick question for you.
Yeah.
If somebody's watching this and they're like, I love what he's saying, how do I get started in it? Well, how would you answer that? How would you tell them this is, go to this website, call this person? What's the best way for somebody to actually start to engage in this? And maybe they have, existing Cisco wireless, or maybe they don't, but what do you think is the best way for them to engage in this?
So I think our website, obviously I'm a little biased, but I think it's an awesome start of kind of showcasing what can be done, what you need in order to do it. Different resources too, recordings of webinars, there's collateral and whatnot here that kind of talks through. And of course, there's actually a product tour as well that will bring you to a pretty much fully populated account, where you can see now what does Spaces look like at a full deployment and what would be my view. So I think this is an awesome tool. I'll put this in the chat window right after I turn it over to Jerry. Get all kinds of different links and whatnot for you guys being able to take those first steps and seeing what is possible on the investment that you may have already made or may be considering.
Okay, and then can I activate whatever I need right here on the website, or do I need to reach out to somebody, a Cisco partner or something like that, to activate this, or what do I need to do to
so as far as activating, you can reach out to the team right from the website here, and then that will trigger to a note to the alias if it's in the form of any type of trial account. The team there, myself, is included on that loop. We can get you set up with it. So everything from account activations, likely some of the audience already has licenses that they may want to activate. We can share the alias to reach out to for it and get started as well.
Perfect. Okay, thank you.
So I'm just going to show, and I saw one, Steve, indoor wayfinding often requires AP densification. Is that typically a challenge for customers? 100%. I'm going to reference your question again in about 2 minutes. And it's such an important question, and kind of now our whole train of thought when it comes to those different check boxes that I had on that slide. I'm going to show just one or two more examples of Spaces and outcomes and kind of layering on that operating system. And some of you may have seen this before, or maybe not, but when we talk about the smart space, part of that is showing that intelligence to anybody that walks in your door and being able to display now, what does building occupancy look like? in our office in San Francisco at 10:30 in the morning on Tuesday? What's the air quality? What's the temperature, humidity? What floors are busy or not if I want to go either to the crowd or avoid the crowd? And then once I click onto this, you'll see that this is that AI powered map, we'll call it a rich map, that has all this spatial context, knowing a desk is a desk, a room's a room, zones are zones. What's the certain capacity of rooms that are either available? This is told to us from the collaboration device, or rooms that are occupied. And this is both on a real-time basis, but will flow into historical reporting as well, where now we can start to understand the hot spots of different floors. I'm going to show also here kind of how this becomes an extension of our ability to continue this experience onto our mobile device. And so being able to navigate right from this screen or kiosk or digital sign, both with a static pathfinding route here, which you'll see, but it will also launch this QR code, and you guys can go ahead and scan this if you want. It will launch what's called an app clip on your device, which now is the kind of the trigger mechanism to bring navigation onto your phone so that you can navigate to the conference room that you want to get to. And again, layering on more value on top of that wireless access point. Now I'm going to show, obviously this is a corporate real estate environment. This is very different than, let's say, a healthcare environment. And the mapping engine that's associated with that and the points of interest are going to be very different, and the furniture elements are going to be very different. What I'm going to show is kind of an early preview. It's not yet rolled out fully and supported, but kind of give you the directionally correct view of how this map is going to translate into something like a healthcare environment. And so this was a map that we did for HIMSS a couple months ago, back in March or so. But you can get an idea, same kind of trend, same theme of displaying all spatial context of what's what in the different points of interest on that space, so that patients or visitors can get to their location quicker and faster, more efficiently. So I can see now that path drawn, I can trigger the navigation onto my device and get there quickly. And so going back to the question, does density matter? Does how many APs I have matter for these types of use cases? Whether it's wayfinding, whether it's tracking infants, whether it's BLE based asset location or ultra wideband asset location, it absolutely does. And so what we've done here is have launched a studio tool that can really kind of be your absolute starting point, your day zero initiation point of thinking through, I know I'm going to want these use cases. What types of access points should I have, and how many of them should I have roughly? And so this is where you can go into your smart spaces builder. You're going to be able to choose and identify which use cases are on your radar. And again, it may not be today that you're going to deploy these. It might be at some point in the next 12, 36, 60 months. So let's say I'm going to be interested in indoor navigation. I know I'm going to want asset tracking with UWB and the advantages that that's going to come with the Wi-Fi 7 access points and the refined location accuracy that comes from it. But I also know I'm going to need to deliver on BLE-based tags. Wi-Fi onboarding is important to me. Let's choose infant monitoring and patient security here, or patient safety as well. And you can mix and match and choose these. What we're going to then do is define kind of what size space we have. So I'm just going to choose 75,000 square foot of space. Maybe this is one building, a couple floors, but we'll say that this is going to be 75,000. Then tell us about what the kind of layout and what the structure is. Obviously, there's different considerations that are going to go into it. And we'll just say that ours are moderate walls and partitions. So now what this is going to do is it's going to shoot out a recommendation on, what's the rough ballpark of AP density and AP deployment that I should be thinking of. And so you can see here, there's going to be different spaces license tier recommendations and packages. But most notably, it's going to also recommend what model access points would be best positioned to deliver these use cases. And then getting into density. So Steve, I think it was you that asked a question around density. You can see this is a pretty high density of access point that we want one access point every 850 square feet. Far different than a density that may be required if I'm just going to do connectivity around the floors, around the buildings. But significant, again, if I'm planning ahead for this, because I know wayfinding is going to come up, I know I need a higher density so that the experience is going to be good for that user on their blue dot. And as I also look at rolling out, in my example here, my ultra wideband use cases, my BLE use cases, and Wi-Fi onboarding. And so now I'm getting the recommendation that in my space, I should be considering about 88, 90 access points. I should be thinking about placing them one AP every 850 square feet. Now, obviously, the next step is where should I put them and how should I place them? And that's where Jerry's going to show off kind of what he and the team are working on and how the next, obviously, crucial part of this process for deployment, how they accomplish it and they help our customers simplify their planning and design pieces. So Jerry, maybe I'll stop here and turn it over to you if you want to show off what you guys have been working on.
I'd be happy to. Thanks, Jake.
Maybe one quick comment when Jerry gets loaded up. I didn't mention this at the beginning. So we do have Hamina is agreed to provide licenses for some of the attendees, for all of you that are attending, good through June 20th. But you're going to have to stay tuned to get that, right? So don't leave early. Jerry's going to present how you can get your license, but and it may not be the very end either. So don't just tune in the last minute. It's kind of partway through. So be sure to keep an eye open for that. So thanks, Jerry. Go ahead. I'm sorry.
Yeah, I appreciate it, Al. Yeah, so just to kind of segue to, this kind of topic around modern wireless design, I think some of the interesting things, and I'll just kind of go through these slides quickly so we can get into the demo here, but, really starting off with, when we talk about modern wireless, is anything kind of beyond, in my opinion, like what past Wi-Fi 6. Wi-Fi 6 is kind of now becoming a little bit not so much dated, but there's a lot of interesting technology that really comes once you start to get beyond Wi-Fi 6. So Wi-Fi 6E, and now as we've been talking about like Wi-Fi 7 as it's maturing here, and some of the other interesting technologies that kind of go along with these Wi-Fi 7 APs. In particular, not to get too far into the weeds here, but just kind of looking at some of the transitions as we go from, if you're still thinking like kind of from that Wi-Fi 6 lens, there's some pretty drastic differences that we need to be taking into consideration into our designs when we start moving into especially Wi-Fi 6E and then into Wi-Fi 7. Not just 6 gigahertz. There's a lot of other things that come into play there, of the wired backhaul, talking about multi-gigabit Ethernet that could be needed depending on your use cases, but then things like new classes of APs, of low power indoor versus standard power class APs, and all the considerations there, or whether we're deploying Wi-Fi indoor or outdoor. Lots of new considerations that come with that. And then how are we going to power all this equipment? Jake talked about all these, these APs, these Wi-Fi access points are no longer really a Wi-Fi access point, right? They're a multi-technology access point. And as part of that requires a lot of extra power considerations of how we're going to power each individual AP, but then holistically, how we're going to power the entire network of access points from a PoE budget standpoint. So we really need, what that kind of comes to is, we really need tools that are going to take us to, being able to design for all these additional considerations. It's no longer just, back of a napkin kind of drawing, isn't going to suffice for that. And at the bare minimum, hopefully you're have been and are designing for, what I'd consider to be kind of the design basics here of, at minimum, designing for roaming, capacity, and some type of redundancy within the network as the Wi-Fi becomes more and more critical. But that's really the basics, right? Beyond that, we need to be thinking about lots of other things in our designs of, yeah, that 6 gigahertz piece like we talked about, but again, the class of AP and what's the right class of AP and the right model of AP for that type of deployment. But then things like ultra wideband UWB, Jake mentioned that, and needing tools that can potentially factor that into your wireless design or your network design, and then how critical the AP location becomes of where we actually place those APs, and then the PoE requirements as well as the backhaul and that multi-gigabit backhaul that may be needed. So what that kind of looks like as far as the life cycle of that process is, we need a tool to help us on the plan side, but then also being able to validate that. And then once we actually deploy that solution, being able to monitor and troubleshoot. And here, this is just going to kind of highlight some of the integration that we have with like the Meraki side. And the same type of integration is actually kind of in development right now with the Cisco Spaces team. So the same kind of concept that we see already in place today will be coming very soon between Hamina and Cisco Spaces of being able to push and pull information to that Cisco Spaces platform. So that takes us to the Hamina Network Planner tool, and that's what I wanted to kind of highlight here and showcase for you guys, and also get you access to this tool. So as kind of Al alluded here, I'm going to flash this up here currently. I'll bring this up here at the end of the demo here as well. So after you guys see the tool, if this looks like something that is of good use for you, definitely sign up for this. If somebody can help me out by maybe throwing that link to the sign up form into chat there, go ahead and fill out that form and you'll immediately get a license key for a 30-day trial of this Hamina Network Planner Plus, which is going to give you all those features and capabilities that I was kind of indicating here. But let me show you exactly what this will get you access to. So I've got Hamina Network Planner Hamina Network Planner pulled up here. This is a browser-based, cloud-based application. So if you haven't seen this before, super simple to get started with. You can sign up through Hamina.com. It'll put you into a free tier Hamina Lite account. But as attending this webinar, you sign up through that form. We'll get you a license key for the full-blown Hamina Network Planner Plus, which will give you all the capabilities of being able to do not just Wi-Fi planning, private cellular, BLE, Zigbee, and Ocean, and even now, as of last week, we rolled out this UWB planning feature here. Just to show you where that is a beta feature. So once you sign up for your Hamina account, you'll have to head over to the beta features and then unlock that UWB planning beta feature by just toggling this option on, and then you'll get access to that functionality as well. But let's do a design together real quickly here. So based on kind of what Jake had put together, let's see if we can meet those requirements using a Hamina project. I'm going to show you two different examples of kind of two different approaches. Let's start with the kind of more traditional, where we're going to just start with a brand new blank slate, new project. Let's say it's a brand new site that we're deploying and bringing up. And then I'll also show you the integration that we have with the Meraki side of being able to pull in information from there as a starting point as well. And like I said, that's going to be coming to the Cisco Spaces platform very soon here as well. But let's say we're going to do our Spaces UWB design, start a new project here. And first thing I need to do is put in a floor plan. So I'm going to go ahead and just grab a floor plan actually of one of Cisco's offices here. This should give us a nice kind of good starting place for, we've got some indoor areas and some open areas, as well as some offices and things like that that we can take into consideration. So the first thing Hamina is going to do by just dragging and dropping this floor plan in here, and the floor plans can be anything as simple as like a JPEG or PNG, but it could be more complex like a PDF or a CAD file as well. Hamina will work with any of those. But the first thing it did here was it automatically detected the scale of the floor plan. It also automatically identified where like walls and objects and things like that are for you. So just like Jake was showing in Spaces, we can build up that 3D model for you that quickly from just a flat 2D floor plan. And that's going to be really helpful for the planning of figuring out, with our design. So by default, we're usually designing for something like -65 on what we'd call the primary signal strength. And then again, for like roaming capacity and redundancy, we're also going to need to factor in like a secondary signal, meaning we need a certain level of overlap. So let's just start with that. Like I said, these are kind of the basic design requirements. This is not going to get us to the level that we're going to need for probably something like UWB or that kind of real location accuracy for some of those use cases. But let's just kind of use that as our starting point to compare. And I'm going to come in here and we're going to use one of those Cisco APs that Jake recommended from the Spaces configuration there. And let's say we're going to go for like a 9178. And we've got a couple of different mode configurations that we can put it in. We'll just leave it in the default here. And we're just going to start with that. So I'm going to tell it to do an auto design for me here, just to, maybe this is just more for budgetary. We're just trying to figure out, depending on the different use cases that we're going to design for, what is that going to look like from a bill of material standpoint and how much is this going to cost? So that quickly we can kind of factor that in. Let's flip back over to our primary coverage. And yeah, did a decent job. You can see as far as the, let's look at our scope zone here and see square footage wise, what are we talking about for this floor? So this is about 50,000 square feet. And we're at right now 19 APs. So 50,000 square feet, 19 APs, that's about 2,600 square feet per AP. So this is definitely not a very high density deployment. And what that's going to equate to is if we're going to look at something like location for maybe even just for BLE, and we want to look at things like tertiary coverage for our BLE, we can see, yeah, sure enough, this is not going to meet that requirement. So if all we're designing for is just good Wi-Fi and having a good primary, secondary coverage for this type of environment, we can see, yeah, this isn't going to be a great location-based design, right? So what do we need to change to kind of factor that in? Well, there's a couple of ways we could approach it. We could do it the manual way, and I could say, okay, maybe we start with the Wi-Fi design from this aspect, and then we're going to add in some additional, APs. Also, let's look at that from a UWB standpoint. Since I did plan for the 9178, we do have that UWB radio. Look at all the radios that are on this thing, by the way. So not just your 3 Wi-Fi radios, but we've also got the BLE radio. We can look at that antenna. We can look at the UWB antenna. That's the UWB radio or antenna signal propagation for the UWB radio, as well as a Zigbee radio on there. So we can factor all of those different technologies into the design, and depending on what that design requirement is. But let's look at the UWB heat map here. If we want to look at just coverage from the UWB radios, that's kind of what we're looking at. So you can see based on our kind of just Wi-Fi design right now, we can see, yeah, we're not going to have great UWB coverage throughout, especially like a lot of the offices and stuff in here. And what does that equate to then for the positioning accuracy, which is usually what we're going to care about the most? Where are we going to have good positioning accuracy? So what this is saying is we're designing for right now, this is pretty aggressive, down to 20 centimeter. Let's make that maybe a little more realistic of, let's bump this up to like 200 centimeters on the higher end, and we'll go to like 50 centimeters on the lower end. So about a foot and a half, a little more than a foot accuracy is what this is kind of representing. So everywhere there's green, that's showing we're going to have good UWB accuracy down to a little over a foot level of accuracy. And we can even validate this using our little roaming man here to see what that level of accuracy is going to look like using a UWB client, and we can kind of see what that's going to look like. And you can see this is kind of what we're expecting that client to look like depending on where it is. If we move more kind of where we're in line with these APs, you can see our accuracy actually goes down because we don't have that kind of triangulation, right? So this is a really good example of how critical that AP placement is going to be when we're doing things like location accuracy and how important that is. So from a Wi-Fi standpoint, this actually works okay for the APs, but from a location standpoint, we actually look at this just moving like one AP, so we get some triangulation here between these APs. You can see how much greater that improved the accuracy in this part of the building. So now if I go back, we'll put our ultra wideband here. You can see now this is looking much better in the accuracy standpoint. So it's just some of those little differences of where we place those APs can make a big difference in that location accuracy. But you can see through the rest of the building, we still actually have very little location accuracy. So let's improve that. I'm going to come back and let's just try and continue to utilize the AutoPlan AP. Not that the AutoPlan APs is necessarily optimized for like UWB placement, but what we could do is we could improve our density of AP, since we know based on what Jake's recommendation was there through the spaces recommendation. It said, you know, we're going to look at more around 850 square feet, I think it was, per AP. Is that right, Jake?
That's it. Yep.
So let's go ahead and up our Wi-Fi requirements to increase that density of AP. I'm going to go all the way up. I'm just going to make one change here. We're going to bump up our coverage requirement here now to neg 60. So default was neg 65. So we're going to bump that up by 5 dB. And let's see where that gets us. I still don't think that's going to get us to that 850 square feet per AP level, but let's just see what that does as far as like our AP quantity. Previously, we're at 19 APs for that 50,000 square feet. And it looks like, yeah, just increasing that up by 5 dB only bumped us up to 1 AP by increasing that from 65 to 60. So then what I'm going to do is I'm going to bump up our secondary, and we're going to say we want to do 62 on the secondary. So that's going to mean we're going to have a lot more overlap in those cells. So I'm going to do our auto plan one more time. And that's the beauty of this, is like we can play around with the different knobs, run through some different design scenarios to figure out exactly, you know, how many APs it's going to take and what kind of design requirements do we need to design for to meet those kind of requirements. Now I could do all this manually as well, but I'm just trying to show you some of the automated ways that we can kind of do this. And we can see, it looks like even bumping up that secondary, because we had the open kind of environment here, didn't really change anything too much. Oh, actually, I did not apply that. Let me try that again. 62. There we go. That's why it didn't change anything. Okay, now it's set to 62 here. Let me try that one more time here. That should see some increase in quantity here of the number of APs. And this will take a little bit longer now to calculate through as we kind of increase those requirements as well, as it's trying to meet some of those more dense AP requirements. But yeah, it's going through, trying to figure out exactly how many APs we're going to need to meet that requirement. There we go. Now we're up to 31 access points, and that's starting to look more realistic of what I would expect for a location-based kind of network design. So let's say, okay, if we go back to our calculator here, we still have our 50,000, but now we're up to 31 APs for the 50,000. So that even still puts us at 1,600. That's only half the number of APs that was being recommended. And let's see if we look at that from a UWB standpoint positioning. We're getting closer here, but yeah, you can see we're still, if we want to have that location level accuracy through the entire building, we can see, you know, yeah, really doubling the number of APs is probably going to get us about where we need to be. Also, keep in mind, you know, the AP positioning is going to be super critical here too, right? And if we look at, let me just have it draw the walls in here so we can see these on the map. But you can see now with all these rooms here, we're really going to need to put an AP in every one of these rooms if we need to get that low location level accuracy. So you can see really putting AP in every other room gets us pretty close. But some of these center rooms, you know, getting that kind of location level accuracy in there, like down to that 1.5 foot level, it's going to require something more like this. So we can see pretty quickly, you know, what that's going to end up looking like, and it should get us pretty close by the time I kind of get this location level accuracy into all these rooms. I bet we're going to end up with something pretty close. And here's another good example of, let's say if we have like a room like this, and I put 3 APs all in a row, versus we stagger those APs out, right? And that was in the design kind of requirements as well, or suggestions here. But yeah, notice like even though we have 3 APs in here, let's look at that from our kind of location. Notice how it still is going to struggle to figure out exactly where that client is in particular locations. And all I have to do to fix that is going to be to give it some triangulation, right? So just by staggering these APs out, pushing them a little bit, not all the way in the corners of the room, but at least giving it something like this. We need to have really 3 good anchors for it to get that kind of triangulation on there, to get that level of location accuracy. And now you can see this is going to look much better as I move the client around. You can see this is what we're expecting. We're simulating that location level accuracy is going to look like. And if I move the client all the way into the corner, you can see it gets a little bit more fuzzy. but still very good location accuracy as that client would or tag or asset moves through the building here. And notice how even we have a little pocket here around the corner where we actually lose that here as well. All right, I want to just pause there before I go to the next kind of scenario that I want to show you here. Any questions? I saw a few bubbles pop up in chat.
There was one question that I answered it just in chat, but it was a question about the sort of the similarity between planning for voice and planning for location accuracy.
Yeah. There's definitely some similarities, but also some very big differences, right? So with voice, we really care about, one, making sure more on the capacity side of things that we don't have too many clients on a given radio for that real-time responsiveness from the AP and the medium on the RF medium. And then the other thing with voice is seamless roaming, right? So you need to make sure that we have good overlap between those APs. So similarly, in that sense, that we need to have that kind of overlap. But what we don't really need or care as much about with like voice is tertiary coverage. We don't need to necessarily have 3 radios or 3 anchors. We don't need that triangulation piece for voice grade. But when we're talking about location, we generally need 3 or possibly 4 anchors for that client to be able to accurately track that asset.
Yeah, great question, Steve, by the way.
So yeah, hopefully this is starting to look pretty, realistic here. We can see as I move my mouse around, it's going to kind of indicate where that mouse is, what APs are able to hear, that asset and that location. So that's going to also kind of help you, where you can see if I go into like this area, you can see there's not very many that are able to track that user. So this is going to help you also in kind of that planning. But yeah, really this client view, being able to simulate that UWB tag, if you're doing any kind of UWB planning. We could also look at things from like a Wi-Fi standpoint. If we want to validate that it's still going to be obviously a good Wi-Fi experience, that's another kind of useful piece of this. So now I've got this client connecting on the Wi-Fi side to see what that Wi-Fi user experience is going to be like. So especially for like the voice grade side of things, making sure that we're going to have a good seamless roaming experience through the building and not have any kind of like either disconnects or like the client's going to be bouncing between maybe 5 gigahertz and 2.4. So we can see here that we're having a good seamless roaming experience through this building, even though we've have this very dense AP deployment for our UWB planning. Okay, let me change gears here slightly and show you if we go to a new project here. We're going to do now starting with an existing deployment that maybe we need to refresh. So the first example there was for like a new deployment. Let's say here's our Meraki Live UWB demo. And we're going to start with a site that has some Cisco APs that are deployed in Cisco Meraki. So in this case, instead of me dragging and dropping a map in here, what I'm going to do is hit the live button. And I'm actually going to pull in from an existing site. So in this case, Cisco Meraki. And again, this is in development right now to bring the same functionality to Cisco Spaces as well. But I wanted to at least just show you what this looks like today with an existing Cisco Meraki deployment. So one thing that Humina can do is it can push and pull information to Cisco Meraki. So in this case, this is an existing deployment that's actually live right now. This is actually our offices in Helsinki, Finland. I'm going to pull in our Meraki deployment that we have at that site, and we're going to take a look and see how things are kind of performing, and then look at, maybe if we want to make some changes to that network to enable something like UWB, what it would take to do that. But at least for now, what I can do is I can see right now, obviously I have no UWB, coverage or anything because the Meraki APs that I have deployed here don't have a UWB radio. So if we want to enable that UWB functionality, I could start with this because one, this is already pulled in where all my APs are located. I can even look at, let's go back to our live view here. And you can see here's our current kind of coverage. So maybe I start with this and say, okay, here's our current design, here's our current deployment. I can see I've got a couple of issues right off the bat. One, this AP here looks like it got, unplugged. Something's going on here. All the radios are disabled on this. So we were supposed to have an AP right here, but that's offline currently. So I need to investigate that. But also I can see this radio here is red. And it looks like the reason for that is because it's indicating we've got two APs that are using the same channel adjacent from each other. So maybe somebody went in there and statically configured some channels, and we need to optimize that as well. So this live view, this is the Humina live view that works with Cisco Meraki today. Space is coming soon, but we can filter down to like a specific SSID. I can look at things like what does channel utilization look like, and we can see everything looks good on the channel utilization side. It's pretty late in the day there over in Europe, so not too surprising there. But I could see like if there's any non-Wi-Fi interference that the APs are picking up, it's going to build a heat map for me on that. Let's look at maybe 2.4, a little bit more utilization there. We're seeing like 38% channel utilization there on channel 6 near that AP. If we go over to the 6 gigahertz side, pretty low utilization there. Let's look at interference now. And yeah, sure enough, I do see a little bit of interference. And it looks like, yeah, if I hover my mouse over there, we can see the little yellow area. It is showing these two APs are slightly interfering with each other, being that they're both using channel 53 on that radio. So yeah, we might want to go in there and reconfigure some settings there on those APs. But what I mainly wanted to show you here was, okay, now that we've pulled in all this information about this particular site and location, I can use this as my starting point to refresh this design. Also, since this is a full stack Meraki deployment, I can also see which switch these APs are connected to, and even like how much power is being drawn from the switch, how many total ports the switch has, and how many ports are free versus available, or free or versus used. So it gives me some indication there. So again, if I'm refreshing this network, I have some good insights to, okay, do I have some power available to, maybe bump up the model of APs on the site, or are we going to have to upgrade the switch as well? Or, if I'm going to add some APs, do I have enough switch ports available to add some additional technology? So what I'm going to do here is I'm going to flip over to what I like to call the sandbox mode. And all I did was, after we imported all that information from the Meraki account, and all that took to do that was a Meraki dashboard API key, and that allows me to pull in all this information into Humina. But now what I can do is I can flip over to the simulation side, and then check this out. If I go back to just like our coverage view, I can actually grab like an AP like this one, and I can say, well, what happens if I move this AP out into the hallway? And we can actually simulate making changes to this environment, all just in my sandbox mode, right? It's not impacting anybody at the site, but I can come up with a complete redesign if need be. I could even just take all these APs, delete all the APs off of here, and say, let's plan to maybe put some new APs into this environment. So let's grab like a 9178. And, if we want to look at what radios this guy has, again, you can see here's all the different radios. So you can see, sure enough, this one does have the UWB. And maybe I want to just simulate doing a brand new design. Alternatively, what I could do is I could just grab all the APs that are currently at this site. And maybe my starting point is, I'm just going to say, okay, let's take those 5 APs, and we're just going to upgrade all of those to something like 9178s. And now we can see, now those are swapped out. It did bring that other AP back online, at least in our simulation here. So we can see once we get that AP back online, this is kind of what we're expecting now the coverage to look like at this site. And then again, we could look at, well, maybe I swapped that AP out, but I also want to maybe think about moving that AP over to here to kind of improve some coverage out in the, the hallway there. We can do things like that. Or I could also say, maybe we want to add another AP here. And then if we flip over to now our UWB side, we can also look at things like, here's our UWB coverage here. And we can see, okay, based on that's our UWB coverage, what about the positioning accuracy? And yeah, sure enough, we're going to need a much higher density of APs before we can get that position accuracy. If you remember, we need at least 3 APs, and with the walls and objects and stuff that are in this environment, we can see we're going to need some additional APs before we can start to get that kind of location level accuracy. So maybe like putting like 4 APs around this area, we can start to see what that is going to look like in this environment.
And you're set to what, 50 centimeters accuracy is your.
That's right. Yeah, this is cranked up pretty high. This is actually at 20
Yeah.
centimeters right now. So yeah, it's a good point. That's probably a bit too aggressive for a project like this. So let's say we go to like 200 on the higher end and then like a foot and a half on like the lower end. And you can start to kind of see what that's going to end up looking like.
Hey, Jerry, quick question. We're kind of coming up on time here, but so I'll let you also maybe reshare that link. And by the way, Alphonsine or Joe, if you could take a look, there was a question on the posting the recording and that sort of stuff. You could maybe address that on the Teams room. That'd be great. So best practice around. I notice you're importing drawings, and then the drawings become 3D. And the tools doing the AI and the tool is doing that for you, which is really cool. Is there sort of a best practice? I know at times when I do that, like I get all sorts of artifacts, right? In that, what is your recommendation around how to maximize the value of that?
As far as like the drawing of the walls and objects in the environment?
Yeah, where auto draws the walls and stuff like that, where you don't get a lot of stray artifacts, right? I may get, it gets confused between a desk and a room or something like that, right? So how do you generally make sure that is there something in the input file that you're using? Are you selecting certain layers? What's your kind of recommendation for that?
That's something that's really actually transformed in the last, even this year, I would say. So let's take like kind of a rougher floor plan here. This is a PDF of a school, but I think what's interesting with this one is these are actually like photos of a floor plan, right? And somebody's hand drawn a bunch of stuff on here. So one of the things that's really kind of changed the game as far as like drawing all these kind of elements into these floor plans is this new feature. And again, this is actually a beta feature, but it's come a long ways that I actually rely very heavily on this now. But this is part of this AI kind of automatic scale, scope, and wall tracing beta. And what this is going to do for you is one, it's going to automatically, even just with like a picture of a floor plan like this, it's going to automatically try to determine the scale. And it looks like it was able to successfully do that. But then the next thing it's going to do is it's going to automatically detect where these kind of walls and doors, at least today, what it's focused on is walls and doors. And yeah, I mean, to your point, if we zoom in here, you'll see it doesn't do like a perfect job with all of these. Like I'll have to clean up a little bit of this, but it actually did a pretty nice job. Even if we zoom out here and you look at like some of this like hand-drawn, marker and stuff on here, it was intelligent to know, hey, that's not part of the building, right? This is somebody drew some stuff on here and actually did a pretty good job of kind of avoiding, just drawing walls on that stuff. So it actually does a really nice job of that. This has actually come a long ways, even just in the last couple of months, I would say. So yeah, I would definitely suggest if you haven't tried this out, try this out, because even on like a rougher kind of floor plan like this, it even does a really nice job of kind of auto detecting those kind of things. But to your point, Al, like then what you can do is once it's detected, hey, I know where some doors and walls are. Now I can come in here and I can actually apply a specific material to that wall to at least save me a lot of time. Now I'm still going to need to go through and, like maybe around the stairs. Let's just do this. I'm going to say auto accept those walls. And then maybe something like these stairs here, maybe that's actually concrete. So now I'm going to come to the manual draw and I could either just draw over the top of this. And I could say, yeah, that's actually concrete around those stairs, something like this. Or what I could also do is, so now you'll see like that's, obviously a much thicker material there than the rest of the walls. But also what I could do is if I undo that, we could also just group select all of this. And I could say, yeah, it's actually all concrete there, right? So you got a couple different options of kind of how you want to represent that. And then you could also, it also matters which direction you go when you drag. So this is a new feature is if I select from left to right, it only selects, the objects that I completely encapsulate into that box. If I go from, from right to left, then you can see it actually, anything the box touches gets completely selected in there. So that's a little kind of power user tip there as well to kind of with swapping those out. Yeah.
I didn't know that.
Yeah. That's a new one. Yeah.
Very nice. All right, we better wrap it up. We're 3 minutes over. but great having you guys. Jake, thanks a ton for walking us through those use cases. Jerry, great to see you as always. And thank you for, every time we get on, I'm learning something. So great tool, great just product that you guys have there. So with that, I guess we'll go ahead and wrap it up. And thanks everybody for joining. And I think there was an answer to the question about posting this recording, so you can go back and look at that and reach out if you have any questions. Thanks a bunch.